Hey Bulldogs, Chris Bryant, the Computer Certification Bulldog here with a combination CCNA and CCNP troubleshooting training video for you. It's a bit of a lab exercise. I've already got it set up for us, very simple config, and we need to see exactly what's going on with the case of the mysterious pings. Because as I tell people when you're troubleshooting, and I don't care if you're going after your CCNA or your CCNP, it doesn't matter. We're always doing a little bit of troubleshooting. And sometimes it's pretty easy to tell when you need to do troubleshooting. If you get called to repair a printer and you go in there and you look at the printer and it's either printing or it's not. And if it's not printing, then you got to troubleshoot it. The reason I'm mentioning that is that with Cisco routers and protocols and switches, it's not always that clear cut whether we have to do any troubleshooting or not. So I'm going to talk about that in this new series of videos for the CCNP TShoot exam, and I want you CCNA candidates to take a look at these as well. Because also it's not enough just to say, obviously, hey, you know what, that's not working. That's not what they're calling us for. They already know that part. But they're saying, hey, I need you to fix this. So we need to identify where the issue is, and one of those two things is going to work in here in a very straightforward hub and spoke network that I'm going to bring up on live equipment in just a moment. Router 1 is going to be our hub. Router 2 and 3 are the spokes. We're going to use the 172.12.123.0/24 network. Last octet, as always, is the router number, and that's it. So I'm not even going to show you a diagram. Very simple stuff here, straightforward stuff. Let's hope it's simple as we tackle this. Now, the one thing I always like to do is make sure, of course, that we can ping where we expect to ping. And I could assume that router 1 could ping router 2 and 3 and so forth, but I'm not going to make that assumption. So let's go ahead and send that around, because we've seen some weird ping results in some of my videos. This one, so far, I shouldn't say that after sending one ping, this one looks pretty good so far. And we'll go ahead and send them all around, and then we'll get to what the actual issue is here. So all the pings are going through, and again, I know it sounds crazy, but bear with me. Just because router 1 can ping router 3 doesn't always mean router 3 can ping router 1. In a more complex lab that could work in. Here we should be fine. So our pings are all fine, and all I've done on each router, I believe we'll see that with a show config as far as EIGRP goes, and I'll do a save on each one while we're looking at that. You can see that I'm using AS100 for EIGRP. I put in the no auto summary command, and I've put in the network, the 172.12.123.0 network. Does that look okay to you, Bulldogs? Does that config, very basic little 3-line config, look okay? Is that mask okay on that network command, do you think? Yeah, it actually is, because we're using a wildcard mask. I know I gave you a moving target there for a second, but this is a wildcard mask. So everything is fine there. And again, we're not even advertising any routes yet, and the reason we're not advertising any routes, and the reason I called you, is that I don't have any neighbors. So let's take a look at the interface one more time. We'll run show interface S0, and nothing tricky here. I'm not throwing you a trick question. But we came in here and someone called us and said, hey, I've got this EIGRP config I'm trying to get running. Maybe you're trying to get it running in your home lab, and you can't get it started. So we don't have any adjacencies, but we could ping with no problem at all. And that EIGRP config looked pretty good to me. And we'll look at it again. You can see my serial 0 config there. Everything's fine there. We sent the pings over. There was no issue. There's nothing tricky there, blocking any packets. And let's see, router EIGRP 100, and that's the same config that I have on each router. So do you see what the issue is? And before I dive into exactly what it is, what I want to mention to you is that I put the frame relay config on first, and then I would ping, and then I would put EIGRP on top, and that's generally the way you would do it. So I get, tweets and emails pretty regularly on this one. It's like, well, I put this routing protocol, and it doesn't matter which one it is, by the way. That's another hint. It doesn't matter if it's RIP, doesn't matter if it's OSPF, doesn't matter if it's EIGRP. I'll have people contact me and say, well, I can't get this to work, but my pings are going through. Well, the issue is, and let's take a look at show frame map. Obviously, there's no problem with EIGRP config here because frankly, we don't have a whole lot about EIGRP config, but even if we had a big complex one, we don't want to spend time troubleshooting at layer 3 unless we know that layer 2 is exactly the way we need it. And that may include a little more than pings, because those pings that you saw me send around, those were all unicasts. And that's fine. These frame map statements are going to carry unicasts with no problem at all. And a lot of you who might not have gotten them for nodding your heads right now, what they won't carry are broadcasts, because the broadcast option is missing from the end of the frame relay map command. That is an option. You don't have to put it in there, as you can see. And your pings are going to go across the frame fine, but your broadcasts and your multicasts will not. So bear with me very quickly. I'm going to put this config on as fast as I can. And I want to show you this. At the very end, this is where you need the broadcast option. Broadcast should be forwarded to this address. That includes multicast as well. And what starts an EIGRP adjacency? A hello packet for 224.0010, a multicast address. So even though the CR indicates that this is a legal command, and that's what I put in, that's not enough for us to get a routing protocol running. Pings were no problem because they were unicast, but now we got to get the multicast going across. And the broadcasts. Thank goodness for the up arrow. And that will take care of it on router 1. Now let's go over to 2. I'm going to do the same thing on each one of those. Cast. You'll have to trust me on the Delcy numbers. And let's put 1 there. That looks good. Go over to route 3. Serial 0. Up arrow. That's an up arrow I'm using there. And we want to... Actually, that was fine, the 2. But we're going to put the broadcast statement on there now. And let's see if we have anything yet. That would be pretty fast, wouldn't it? And there's .2 already, and I think we're going to see .3 very shortly. .2 has already been up for 22 seconds. And there's .3, it just came up. So something just that small stopped our adjacency from forming. And what I do teach and what I do in the real world is when you configure something and it's not working, you tend to look at the last thing you did. That's usually what caused the problem. But here, we could put EIGRP on top of that previous frame config. We could put RIP on top of it. We could put OSPF on top of it. It wouldn't matter. It's not going to work unless we've got that broadcast option to allow our frame to carry our multicast and our broadcast. So if you just don't see the issue at layer 3, maybe you need to drop back just 1 notch and take a look at layer 2. Plenty of other TShoot videos and CCNA videos on the way, so make sure to subscribe to my YouTube channel, and I appreciate you watching today's video.